4.6 is congruence in right triangles. So we have SSS, side, angle, side, angle, and angle, side. The last way to prove triangles are congruent are in right triangles, which is the hypotenuse and leg theorem. So the theorem says if the hypotenuse and one leg of a triangle are congruent, then the triangles are congruent. So you have to know that it's a right triangle, so it has to have a right angle, and the hypotenuse has to be congruent to the other hypotenuse, and one of the legs has to be congruent. So number 1, triangle XYZ is isosceles. So XYZ is isosceles. From vertex X, so we know if X is the vertex, then these two are the sides. A perpendicular bisector is drawn to YZ. So we know it says explain why the two triangles are congruent. So this should be M right here. So it's asking why are these two triangles are congruent. So I can mark in that these two sides are congruent by the reflexive property. So I have the hypotenuse is congruent to the other hypotenuse, and it shares a leg. So that means by HL, hypotenuse leg, they are congruent. Okay, so I didn't leave much room for this, but so the given is angle ABC and angle DCB are right angles. And we're also given that AC is congruent to DB. We're trying to prove that these two triangles are congruent. So if I can only use HL if I write down that the triangles are right triangles. You cannot write HL until you write down that the triangles are right triangles. So I can see that they are right angles, ABC and DCB. So I can write that triangle ABC and triangle DCB are right triangles by definition of right triangles. So just definition of right triangle is that it has a right angle. So we were given that they had right angles, so now I can say that they are right triangles. So right now I have the hypotenuse is equal to the other hypotenuse, and I don't have any shared or a leg, but I can write down that CB is congruent to CB by reflexive. So now I have the hypotenuse and a leg in a right triangle because I have written down that it's a right triangle. So I can copy down that triangle ABC is congruent to triangle DCB by HL, hypotenuse leg. Number 3, tell whether the HL theorems can be used to prove the triangles are congruent. If so, explain. So letter A is kind of like the previous one. I can write these two are reflexive. So I do have a right triangle, and I have the hypotenuse, which is opposite the 90, and a leg. So I'm going to write yes. And then B, the triangles are congruent, but not by HL. If it was HL, I'd have to know the hypotenuse, because the hypotenuse is across from the 90. So this is no, not by HL, but would be by side, angle, side. And then C, I have the hypotenuse on this angle because it's across the 90, but I don't have the hypotenuse on this one, so this is no. The hypotenuse is across from the 90. Alright, I wrote my two givens in. So the first one I'm going to mark. MJ is perpendicular to NK. Oops, I wrote that wrong. NK. So perpendicular. So that means that angle MJN and angle MJK are right angles by definition of perpendicular. It also means that these are right triangles. So triangle MJN and triangle MJK are right triangles by definition of a right triangle. I need that because at the end I'm going to use HL, and I can't write HL until I have in my proof that they are right triangles. I need to mark my second given, which is MN is congruent to MK, which, by the way, those are the hypotenuses. So now I can also write that MJ is congruent to MJ by reflexive. So I have a legs are the same, and the hypotenuses are the same. So that is enough to write that the two triangles are congruent. So triangle MJN is congruent to triangle MJK by HL. Now, you can only use HL if you have in your proof that the hypotenuses are congruent, which I do, that it is a right triangle, which I do, and then the legs are congruent. One set of legs. Okay, and I wrote the given in for each of these, and I also have some markings on my given. So I am trying to prove that two angles are congruent. So the angles that I want to prove are congruent, I'm going to mark in red. So I want LMX and I want NMX. So that tells me I'm going to be dealing with triangles that make up that. I know at the end I'm going to write CPCTC. So let's start out by using our given. So ln bisects ML. So that means that MO is cut in half such that OX is congruent to XM by definition of bisect. So I'm going to write that in. Those two parts are congruent. And then MO bisects NL. So if NL is going to be cut in half, that means that LX is congruent to NX by definition of bisect. So I have these two right here. So what I see is I don't have, let's see. If I'm trying to prove that these two angles right here, I was thinking I would do it differently, but if I have these two angles right here, I'm just going to look at these blue triangles right here. Because I'm given that this is a right angle, so I can write that this is a right angle. So I'm going to write down that angle LXM is congruent to angle MXN by all right angles are congruent. So now I have two segments that are separated by an angle, so I have side, angle, side. So I thought I was going to use HL, and I didn't. I mean, maybe I would use it. There's all different ways that you can do this proof, I guess. I was thinking it was going to take a different route, but I'm not even going to use HL. So I'm going to write that the triangle MXL is congruent to, so if I did MXL, MXN would correspond with it by side, angle, side. So since we want to know that the angles are congruent, I'm going to write LMX is congruent to angle NMX by CPCTC. Because if I know that these two triangles are congruent, then their corresponding angles are congruent right here. So sometimes you might, I totally thought I was going to do HL and I didn't really need to. Even though it's a right triangle, I had side angle side and that's good enough.